Hello, welcome to the Data Channel. So today we are excited to bring up a new topic in Databricks, that is Lakebase. So you are hearing it right. So it is not a lake house. We're talking about Lakebase today, which is a latest topic. So which is just announced by Databricks a couple of days back. And so we will be explaining about what exactly the Lakebase. So if you're interested to know what exactly this latest topic is, and we'll be having a detailed video about this Lakebase. In today's video, we will discuss that. So if you're before proceeding, if you're new to this channel, we would recommend you to please subscribe and also press bell button for instant notification. So let's get started. Yeah, so this is the topic that we'll be discussing in today's video. So it's a kind of a agenda for this video, right? And if you closely see, so we will be discussing about why lake base matters more than ever, right? So what is the importance of it, and right? And what is the importance of lake base in terms of business and architectural gap? What exactly this fills, right? How it contributes to fill that gap, and also we'll learn about its power in AI applications and real-time data applications, how it actually simplifies application development and DevOps, the true impact of Postgres on Lakehouse. So basically, this is what if you see this video at till the end, so you'll understand how exactly this the lake base enables certain topics that we are seeing in this particular slide, right? So without any gap, we will jump to the next one, where we will start discussing about why lake base matters more than ever today. So here is the reality, right? So your transactions live in one world, like it might be PostgreSQL or some other OLTP systems, right? And your analytics platform is in the different platform. It might be in data warehouse, it might be lake house, delta lake, data lake, etc., right? So, and the glue holding them together. So that is, what is the glue? That is fragile, right? So that hand-rolled ETL pipelines are there. You have slow, complex, and those are prone to break anytime. So that is the operational challenges that every data engineers or data engineers or operation team faces, right, on day-to-day basis. So basically, every time your app writes data, you will have to wait for it to sync, right? Every time your analyst asks a question, so they are looking into the stale data because your pipelines are not in sync. That is, your OLTP and OLAP systems are not exactly in a real-time sync. And every time your ML model needs training, so it's already the data might be outdated, right? So OLTP databases have not fundamentally changed if you take since 1990s, and even when deployed on cloud, so these legacy databases are pretty slow and expensive to provision and manage. Operational databases are typically deployed in a separate stack from the analytics platform, right? And this create a silos between transaction systems and analytical systems. So that is where the data is in different data between. I mean, the data is actually having that siloed view. One is a transactional and another is analytical. So moreover, these databases also do not fit into the modern development workflow needed for AI development, right? The transactional architecture typically involves separate databases for development, testing, staging, and production, right? Environment. So that is what we were talking about. The CI/CD comes into picture, right? And each provision populated and maintained separately. So that is how the complex CI/CD pipelines looks like, right? And Databricks Lakehouse is a first of its kind database, which is built on a open source standards with a high scalable architecture based on a separation of a compute and storage, right? Specifically designed for a modern application development, Lakebase is deeply integrated with the Lakehouse. That's already a, Databricks uh, tech stack to make it easier to combine operational, analytical, and also the AI ML stacks, right? So if you move to the next slide, so basically we'll be discussing here the continuity part of it, more why lake base matters more than ever today, right? So here, if you take this is what we'll be doing on a day-to-day basis, right? So modern data apps don't wait, right? So they demand the best of both worlds. So like if you take OLAP systems and OLTP systems, typically you have a source data, you have a user sitting at the other end. In between, you have a data warehouse and OLAP. That means there's a OLTP systems, OLAP systems, and then finally this data is consumed by the business users via reporting, ad hoc queries, or it might be the business users, right? Any like the end users typically will be consuming the data from OLAP systems. So now if you take modern data applications, right? So definitely we don't want to wait because here we have a ETL pipelines to bring the data on a scheduled basis. Even though it is a scheduled basis, it might not be a real time. It might be a batch or micro batch. So streaming is again mostly like not for all the applications, right? Considering the volume of the data and the behavior of the data and the business requirement. So that's what like the expectation from the real world definitely would be like the dream scenario would be, right? Instant writes and updates from the OLTP system should be reflecting into the reports, right? And the massive scale querying predictions and real-time insights of OLAP and AI. So they need speed and scale, precision and also prediction. So that is where Lakehouse comes in here. So the missing link that was there. So the Lakebase unifies OLTP and OLAP in one platform. Basically, by embedding a fully managed serverless post-GRE engine. So the post-GRE engine is the heart of this architecture, right? So that serverless post-GRE engine directly sitting inside the Databricks Lakehouse here. And here we no more syncing of the data, no more waiting. Your application writes a record, right? So instantly it's available for analytics. That means so the OLTP, OLEP, the gap that was there, so that is filled using the lake base here, right? So that is what like if there is any transaction happening in a OLTP system, so there is no need to wait. Your app writes or wants to read the data, so that is instantly available to the analyst in the OLAP systems, right? So your model wants to score or train. For example, you have AI ML use cases, and it can really use the real time data, live data from operational engine. So that's you can imagine the advantages, the use cases that we have, right? It might be the analyst who is using the data, they gets the real-time data. It might be the AI ML models who are referring to the live data, they are also getting the live data. And also the as a data engineers or the data team who are actually juggling to fix the pipeline issues, making sure the data is flowing from point A to point B, that is OLTP to OLAP system. So that's no more the problem here, because that bridged that those OLAP and OLTP system are bridged in real time using this post-GRE engine. So the Postgres engine. So that is the concept of Lakebase, right? So that is where the Lakebase is solving that. So Lakebase brings that OLAP and OLTP together, and it is a fully managed service, right? And finally, so what we get here is it's like no more fragile pipelines, right? So no more delays. It is just one powerful unified platform for building modern AI and real-time data applications. So the feature of data isn't separate, it is unified here, and it starts with Lakehouse. So next, moving on, so Lakebase, what exactly it is, right? So if you dig deeper, what exactly this is like, how exactly, I mean, technically what exactly this is, right? In detail, if you want to look into, right? So basically, in traditional stack environments are managed manually, right? You spin up a different databases for development, testing, and production, each with its own overhead. So analytics live on a separate system, and EIML pipelines are stitched together with a like a tape and cron jobs, duct tape and cron jobs. So in contrast, basically Lakebase offers a unified platform here, right? whether it is operational transactions or a machine learning model interfaces. It's all one in one place, and it is scalable, fast, and built with the AI developer in mind. So that's pretty interesting because Lakebase is looking from the AI perspective, right? Because unless the AI is made kind of easier to develop, and also kind of the data that's AI required is easily available. So that is the power of like monetizing the AI completely, right? And so that is a deeper integration with the Databricks ecosystem. Ultimately that is what's happening, and it is also separating the compute and storage for scalable performances, right? And also it is based on the open source standards that we discussed, and Lakehouse architecture. So Lakehouse architecture is again a fundamental of it, and Postgres database or OLAP system basically OLTP system basically it sits at the heart of the architecture. And so moving on, yeah, when we talk about a traditional stack versus lake-based stack, so this is already we discussed. So traditional stack is nothing but like when you take traditional stack, so you have separate DBs for development, test, and production. But in lake-based, it is unified. It is isolated environments we can maintain in one place. And OLTP and OLAP were siloed in terms of traditional stack, but here it is unified via Lakehouse. And here you need to have a manual scaling in case of a traditional stack, but in case of a lake base, it is more of auto scaling with separate compute and storage. And here you have poor AI integration. So here you are having a good integration of a native AI plus ML workflows, right? So moving on, so Lakebase, how exactly it is built? Like, so if you take from the architect point of view, right? So how exactly it is built, if you want to understand that. Basically, it is built on strength of Postgres. So that's what we were telling the PostGRE. Postgres is at the heart of it, right? So basically, at the heart of the Lakebase is Postgres SQL, the world's most popular open source relational database, and developers already love it. The tooling is mature, and modern AI agents are trained on the data that aligns with the Postgres ecosystem. And yes, it supports powerful extensions like Post GIS for geospatial workloads, and Page Vector for AI embedded search. So you can blindly, truly intelligent apps right out of the box, right? So that is a strength of Postgres, and we are leveraging that strength in building the Lakebase here. And the next is cloud native architecture. So Lakebase embraces the cloud native principle of separating the compute from storage. So this isn't just about elasticity. It means you can handle high throughput workloads with like sub 10 millisecond latency, and scale effortlessly to support thousands of queries per second, right? And because of it's fully managed by Databricks, you don't need to worry about provisioning VMs or maintaining the infra. So just write code, and you are ready to go, right? And the next one is zero copy branching. So what that means is basically one of the Lakehouse coolest features, right? So this is branching. So think of it like a Git for your data. So you can spin up an isolated branch of your production database in seconds, no copying, no download, or no downtime, right? Whether you are testing a new feature with a real data, or recovering from a bad deployment, and Lakebase gives you surgical control over your data environments, right? That level, I mean, surgical in the sense it gives granular control to control that environment. And next, if you take a summary, right, a new class of database, right? What this means is basically Lakebase isn't just a database; it's a new class of operational database, tailor-made for data today's intelligent applications. So, with the power of Postgres, cloud-native performance, and AI-native integrations, it gives you the freedom to build safer, faster, and smarter application. Whether you are scaling a startup or modernizing a data platform, so Lakebase should be your foundation, right? Yeah, and built for reliability and scale. So reliability is non-negotiable for modern applications. Lakebase delivers multi-zone redundancy. So even if an entire zone goes down, so your data and compute are safe. Readable, it will be able to read from the secondary storage, and you have a high availability. And you can also have a horizontal scalability for reads, and with the data which is encrypted, regionally durable storage. Every transaction is protected and recoverable even days later, right? So now let's take a certain when you talk about lake-based potential use cases, right? So that means with the use cases with the power of a lake base or the advantages of lake base that we have seen, what are the this is just a few samples or examples that we can think of, which might be a potential use case and bring like a profits or business and get from this benefits, right? Basically, the first example we can take is logistic and fleet optimization. Um, let's take example of this use case where a logistic platform logs drivers' check-ins, delivery statuses, and location pings into Lakebase. AI models optimize delivery routes, predicts delays, and auto notifies customers all in a real time, right? So in this scenario, what happens before Lakebase is it is like fleet tracking data required syncing to the separate platform before running the optimization models. But with the lake base, what happens is location data prediction and automated customer messaging are powered by unified real-time data layers, improving efficiency and customer experiences. And if you take similarly the insurance claim automation, so where the scenario or use case might be when a user submits a claim, so Lakebase logs the transaction document and document uploads and claim metadata. So AI model scores the claim for the fraud risk and route it to the auto approval or a manual review, all without a data movement, right? So before Lakehouse, the problem is like the claim system and the fraud detection engines were separate. Syncing data latency and the operational capacity complexity was a problem. So, but with the lake house, the potential advantage is the operational transaction and the ML fraud scoring are run together without duplication, enabling instant decisions of the claims, right? And have the right uh, settle them in the right time, right? And the next use case we can think of is an AI financial advisory platform, right? So here, if you take example or a use case, a fintech application that tracks a real-time portfolio activities, right, and suggests the personalized investment opportunities using ML, and explains the risk profiles using an embedded LLM assistant. So let's take that as a use case, right? So before Lakebase, the required syncing user actions from OLTP to the analytical engine for ML interfaces, often it might be delayed, right? But with the lake-based user activity, model serving, and LLM explanation are natively integrated, enabling real-time financial insights without data duplication or ETL. So the next final use cases we can think of is a healthcare, remote monitoring and diagnosis. So use cases, you can take a telemedicine platform records the vitals and symptoms from the wearable devices and the patient forms into Lakebase. Real-time risk scoring are generated using machine learning models, and recommendations are presented directly to physicians via AI interfaces. So that might be the use case, right? Before Lakebase, the thing here is we need to stream the data, healthcare data had to move to a separate analytic layer before risk models could process it. But with the Lakebase, patient vital diagnosis models and the AI summary can run in real time on the same platform, accelerating care and reducing the clinical delays. So you can think of these scenarios, but the end benefit is same, which is we are talking about the reliability, scalability, and more faster customer experiences, better customer experience, right? And So that's the potential benefit of the lake base, right? So you can think of different scenarios and use cases. You can comment in the comment section if you have if you can think about different use cases here, right? And so if you see the concludatory part of it, right? So in the world where data is the fuel for AI, right? Real-time decisions and the customer experiences. So we can no longer afford fragmented tech stacks, slow ETL pipelines, or duplicated data efforts. So that's where the Lakebase is not just another database. It is an reimagined foundation for modern data applications. So it basically is kind of a unifying operational transactions here, right? And analytical processing and AI models serving into a single lakehouse native architecture. Lakebase is empowering the developers and data teams to build smarter, faster, and more scalable applications, all without leaving the Databricks ecosystem. That's important. And whether you're running a real-time recommendation engine, building a smart IoT dashboard, or deploying LLMs powered applications, so Lakebase gives you the speed of OLTP and intelligence of AI, the simplicity of the single platform. That's about the Lakebase. And if you're excited about the Lakebase, can unlock for your data and AI strategy, don't forget to like, share, and subscribe to this channel. If you got any questions and or want to deep dive into specific use case, drop them into comment below, and and try to respond. And thanks for watching. That's about it.